All right, well, good morning. Welcome to SQL Server, SQL Relay Cardiff. Is that where we are?
Yeah.
Is everybody from Cardiff? Anybody not from Cardiff? So, where are you from?
From Pembrokeshire, which is even further, near Ireland.
All right, well, welcome. Thanks for coming. Is anybody their first SQL Relay here today? Quite a few of you. Okay, good. So we've done this a few years in a row, and so we'll do it again next year. Enjoy it. Let everybody know how you put that. I'm going to talk a little bit about version control here today. Before I start, I'm just curious, how many of you are developers like to do C# or Python or Java or something? A few of you. And DBA is primarily the database work management or development. Okay. How many of you use version control right now? Not very many of you. Alright. So hopefully this will help you out. These are our goals. I want to talk to you a little bit about how we do database code and version control together. For those of you that are application developers, you're probably very familiar with how I store C# code or VB code or Java code into a version control system. And why we do that, how we handle it. A lot of DBAs have never done this. We've never dealt with it. So I kind of want to show you how this works. I'll give you some of the benefits here in terms of tracking what might have happened, as well as talk about branching and merging a little bit. And try to show you how that is slightly different with database code than with application code. So this SQL Relay, it's been going on for 2 weeks. I was in Bristol yesterday, and I'm here today. That's it for me, but there's certainly some people that are coming and going across all these different events. So if you move, there's still a SQL Relay near you, and then if you've got friends, colleagues, people in your company in other locations, please let them know, because I think it's a great event. Free is always nice. So who am I? I'm Steve Jones. I run SQL ServerCentral. Some of you may have heard of that. I may use the site. And really, our goal at SQL Server Central is to help you get better at your job every day. We publish information, questions, things like that to help you learn more about SQL Server. I've been a DBA and a developer since about 1989. I've been working with SQL Server since about 1991. So I started working on version 2, and I've worked with all the versions since then through, I guess it's going to be maybe version 13. 14, I don't know. We'll see what SQL Server 16 turns out to be. I work with big and small companies in the U.S., a variety of industries, financial, education, power, utilities, different things in my career. So I've had a bunch of experience both managing SQL Server databases, which will be able to build applications, as well as building my own software that runs on SQL Server. Here's my contact information. Please feel free if you have questions later, you want to contact me. And I have this at the end as well. So, for these new DBAs, one of the things over the last few years that a lot of companies have started to do, maybe really starting in the late 90s with the Agile movement growing, creating extreme programming, pair programming things, is we want to bring some engineering to our entire software process. And this really comes about by trying to be more disciplined in what we do. It's not trying to slow us down, it's not trying to more overhead, but just being disciplined and being repeatable in how we put software. So we want to make sure that developers, when they write code, that they always put it into some version control system so that we know that we have captured all the work that's done, and we know particularly what versions of every file or every piece of software work together or don't work together. That's really the key there. We also want to make sure that we are using some sort of continuous integration process, which means that we are taking all of the code and we're putting it together on a regular basis, preferably on every check, preferably every time. And we're testing it in an automated fashion. Those of you that are developers probably have learned to write unit tests. We in SQL Server typically haven't learned to write unit tests very well. Most of us run a query, run some code, run a query, and then code. It's great. But we don't necessarily do that every time we make a change. The whole idea of continuous integration is we don't depend on the human to do that repeatable task of making sure they run every test over time. We automate it. And from there, we move into a process of release management, which is nothing more than making sure that however we're going to deploy changes to our clients or to our customers or to our servers is the same every single time. So that when I deploy the test, it's the same way that I'm going to deploy to production. When I deploy a user acceptance, it's the same way with production. And it's just about having a process in place. This could be PowerShell, this could be some batch file that you run, it could be anything that's out there. The idea is just to have some kind of formal process that's lightweight, but it just works. If it doesn't work, we find out why, we fix it, and then every time from then on, deploy software. We can do all this with databases. The whole idea is that we want to try to bring some engineering to how we make database changes so that you're not trying to update scripts the night before you deploy to production and you're sweating and you're worried that it's not going to go or the database is going to go down or something else is going to happen. The whole idea is just to make this a little more fun. All right, so what is version control or source control or vision control? Here's a long, drawn-out definition of Wikipedia, but essentially it's just keeping track of what changes have been made in the file. How many of you have ever written a stored procedure or you've written a Word document and then you decide to change something, you save it as My Document 2? How many of you have done stored procedure 3, stored procedure 4? Okay. That's version control. It's a rather poor way of doing version control. There are certainly better tools for doing version control. But that's the idea, is to just keep track of every time you make a change. But we do it in the same file, so they don't have to look through 2 files and try to figure out what's wrong. We have a way of determining what's different between those files. And that's the whole idea here. It is called by all of these terms. It's kind of changed over the years. Version control seems to be the most common term that's out there. I've got all these quotes up here from different places, but how many of you are perfect developers? Never make a mistake in script? Never put a bug in a piece of software? Anybody? I'm not. I make mistakes all the time. That's okay then. That's part of what is great about this business is you can try these amazing things and see if they work or don't work. And it's quite unlike most other things in the real world where if we try something, usually it's more of an effort to throw it away. It's cost money. It's a bigger deal. In the virtual world, we can just try things. If they don't work, we undo them, go back the other way, try something new, move forward. And that's what version control really gives us. All these other things kind of say that, as professional IT people, we want to make sure that we capture everything and that we make this smooth and easy. And it really is fairly easy to do. And then we just build these habits so that we're aware of what's happening over code. We're bringing engineering to our process. I don't know about you, but I'm slightly embarrassed that after 50 years of computing, we build really crappy software quite often. I think that we would be much better by this point in time overall. A lot of it is because we haven't really brought any engineering to our process. We all think we're great. We usually do good work. But we make lots of mistakes. The thing is, we're not doing a good job of removing those mistakes over time. Version control helps us do this, as well as following just some more good practices of learning what goes wrong, what doesn't go wrong, making sure we don't repeat those mistakes, keeping track of that. And that's what version control really helps us do. All right, so let's get started. I'm going to show you hopefully a lot of demos and not as much stuff. But really, creating or getting your database code to version control follows these 3 steps. Okay? Create a place in a version control system. Probably most of you in your company have one somewhere. Maybe somebody administers it, maybe they don't. If you don't, there are free version control systems out there. You can get Git or Mercurial or Subversion for free. Microsoft gives you a limited amount of people that can use Visual Studio Online and TFS for free. Really no excuse. But however you do it, you want to create a place, a repository, script out our code. If anybody doesn't know how to script out your code, it's pretty easy. I'll show you how we can do that real quick. And we put our files in there. That's it. And as we make changes, we kind of follow a similar process. We pick a file, we change it, save it, we go back. Right? Sound easy? So let's do it. I know you all are British or Welsh, but yeah, there we go. A little enthusiasm. You can speak up. Nobody get upset here. All right, so I'm going to use Git because that's really loud. I'm going to use Git because Git's rather popular right now. I like Git. I think it's my favorite system. And it's a decentralized system, so it works a little bit differently than TFS or Subversion or Vault or Perforce or some of the other ones out there that rely on a central server. In Git and Mercurial and a few others, there's peers. So that nobody is the central server. You just have peers where we exchange all of our source code. Typically, we do stick one server out there as the peer that we all go to and pull from, but we don't have to. So I've got a few databases here. I'll skip this one for now because I just want to do a setup. Here is a brand new database. It's got stuff in it, tables, views, stored procedures, all that stuff. Hopefully nobody's confused by how that works. So I want to put this into version control. I want to have some way to do this. Now I've got a place on my machine here, a folder, nothing magic about this, simple folder, and I want to put a repository here. The nice thing about Git is that I can put a repository there like that. I think all of you could probably do that, right? That's not too hard. And I've got a repository. I can connect this repository to other repositories. Anybody can do this on a machine. Very simple to do. So now I need to script out all my files. That was the second step. Now there's a few ways to do this. I certainly could do this. Some of you have done this before, I'm sure. Generate scripts, and I say I want to include everything, and then I want to say I'm going to put, oops, I don't want to do that. I'm going to make a file for every object, and let's put this somewhere. And I say, go. Why didn't it let me say? To get it the right file name, I guess, huh? SQL relay. There. All right, that's easy enough to do, right? In this case, that will put all my objects somewhere over here. My relay folder. And I have all my objects there, right? Some of you may have done this in the past. There are PowerShell or VBScript, various interfaces to attach to SMO and actually do this for you automatically if you wish. Any of them would do it, but I can get all these files out of there. I'm going to do it a little differently just because that's a slightly cumbersome process to work with over time, but it works just fine. There's nothing wrong with it, okay? I'm using a plugin. I work for Redgate Software, and so I'm using a little plugin to do this, only because it makes this demo go really, really quick. But all of this is really doing is it's going to do the file save and push out and script out the code to a file. That's all it's going to do, okay? So in this case, what I'm doing is I'm going to put this in that folder that was here. Now, all I'm doing is saying this is where I want my script files to go. This is where you put them. And so if I say, you can see I've just got all of my code here. This is the same thing that essentially is happening with that other process, the SMO process. I think we're just using SMO things too, but and I've got all my code through, all my tables through there. Right? They're slightly more organized, but you could do this. Right? It's not, I'm sure all of you could make folders and say tables and store procedures and all that stuff and script everything out. Okay? The point is, though, everything is committed in source control. So if I were to actually look now at what my status is, it's clean, which means that everything is in fact committed and it's captured. Right. Now, I've already done this with a different folder here. I've got this folder that's got a Git repository and database in it with all of my stuff here. Hopefully you believe it. That corresponds to this database up here, where I've linked in all this code. And that corresponds to, in source tree, I have a look at my Git repository because it's a little easier to actually look at what's going on. Okay? And then here, I've been making lots of changes over time, so I have history and things like that. So if I wanted to make another change and see the difference, I could do a couple of things, right? One is I could I think I have a 2 there, so let's do this. I could create code, right? Everybody does this stuff. You work along, you know. Do this. Let's pick that there. We can do this all day long, right? Make code, write store procedures, write tables, views, change things, all that kind of stuff, right? So then when I go to periodically, what I want to do is I want to commit this. So I could sit here and go, all right, what's changed? I could keep track of this stuff one by one. Come on. Wake up. In this case, you'll see there's the store procedure in a table that I just made. You know, and if I scroll through, I'll see the code that's there and stuff, right? So there's there's nothing magic with doing this. I could say, we'll do this. I'll commit that. And all that's really doing is scripting out that code, that object that I created, saving it into a file. So if I go to my source control system, there's my store procedure here that I just changed. And there's my table over here in the tables area. Alright, agree with me? Nothing magic there, right? And if I look at my source tree, I'll in fact see in a second when this updates that I've gotten a change up here. So there's my comment, or look at this change set. And here's my code. I can look at either of these files. They're committed together, so there has this batch together. So if I'm working on a series of things that are all related, I want to put them together. Certainly, if I was working on .NET code as well, or Java code at the same time, I could have a folder where I'm putting those things in. And with something like source tree or various GUIs, I could commit that stuff together. So I could say, here's a new web form, or here's a new Windows form that I've created. Here are the source procedure, the objects that go with it. Put those all together. They could all appear here. I could have my comment that says, this is why I made this change. It's actually here. And I can look at my code. Okay. Does that make sense? Any questions? Okay. Simple enough. Just to show you what I'm really kind of doing with that plugin, there's nothing magic here. Is that this is how I actually used to work in source control before I worked for Redgate, before I had this tool. I would go to the correct folder. So let me find my folder here. And I did this in 1999 with Visual Source Save. So I could pick some table. Let me just pick this one. And I would open the file just like that. File open, pick this file. And I say, I want to edit it, or I want to do something else. In this case, we just make a new table because it's easier for me to do this. Execute this. Then it's a new object. I have to save it. So let's do save as. Let's call it 3. We'll save it right there. That file will appear here. And there's various GUIs here. So I see I've got an uncommitted change. Git, I have to stage a file, commit it, and I say table, commit that. Okay. Now this is now in my source code repository. It's in my database as well. It's also actually here in memory in this particular tab. But I've been able to just move that stuff. And for years before we had some of these tools like the plugin I'm using, that's what I did with developers. And
I want to ask, is it possible to put this security structure to version control as well?
is it possible to put security structure in version control? You mean users and roles and things like that? Absolutely. Yeah. I mean, I could. I'll just do that for a second. So, if I want to create roles, right, I could do that. In this case, when let's refresh this, it'll say, my resolution doesn't like this projector slightly. Commit that. It'll appear here in just a second. I could do users, I could do anything I want, essentially, right? This plugin only does database stuff, but I can certainly do server level stuff and just do a file save. I think all of you know how to script out changes you make in the GUI. Does anybody know how to do that? So there's a little save button in the upper left-hand corner that has a little squiggly thing on it. And if you pick that, it'll actually just give you a script. So if you change a server setting or add a login or anything like that, you can script it out rather than just making the change in the GUI. And I can do a file save just like I did, and then commit it in through source tree or towards Git or whatever type of version control interface I have. It sounds like a lot of work, but it's not a lot of work. It's really just building a habit. That you make changes, maybe you make 4 or 5 or 6 changes, and then you commit them all to source control so they're there. Now in the Git world, the important thing is that this stuff exists on my machine, but I want to get it out to other people. So I can push it from here. I've got a push thing here as well. You'll notice this pops up to say, push this thing. So let's push it. And what this does is, I actually have my local Git linked to GitHub. So if I were to look out at my GitHub place, you'll see that I've got these various items here that I've pushed out. Wow, this doesn't like this resolution at all. Here's the role that I just created, and all this stuff has been pushed out to GitHub. Out in, I don't know where GitHub is, but wherever they are, that's where it went. Now, how do I share that with somebody else? Well, I have I have a VM here for my colleague Jonathan, and this is all under his login, which he probably loves, but I have the ability to pull all his changes in. So I make changes in my place, I'm pushing them out to a central server at GitHub, and he's pulling them down. If you use TFS or Subversion or Apache, Vault or some of the other centralized ones, it's a very similar model, except that you have to push it to the server. You can't kind of do that local thing where I did to a folder on my machine. Does that make sense? Okay. So you can see I've got all these changes here. Let's zoom in. Let's not zoom in, maybe. Well, let me fix that because otherwise this gets really annoying. You guys can't see anything. I can barely see things too, so. Oops. Sorry, confusing myself. There we go. So this is much easier to see. And certainly I could read the GUI and I could open up each one of these files if I want to execute in my system. I'm sure all of you are capable of writing a piece of PowerShell or a piece of VB script that just says, go through and execute this stuff that's in this folder and run it against my SQL Server. It's not very hard to do. You can see the changes that I just made have now appeared in a different system. So I can easily pull those into my database so that I can work on those changes, and then the tracking is on the track here. Leave it there and see. So I created some short procedure somewhere, and update. Well, trust me, it's there somewhere. I don't know why it's this one. Good. Change this too. So you can see my tables there as well. All right, does that make sense? Agree with me?
Excuse me.
Yes, sir.
And so is there any way before you apply those changes to compare the changes made or whoever is made with the current state of your database?
Is there any way to compare this? Yeah, so if I'm, go over here so that I can see that. So that's the idea of comparison. So if I make a change, let's make a change. So if I pick a procedure, let's just pick something. Okay, so I'm going to change, I'm going to add an alias here. Right? Hopefully you realize that's probably a bad change because I've altered my result set now between two different ways. When I go to commit this and see what's there, and it doesn't matter whether I'm pushing out or I'm looking at what changed in source control, it doesn't matter. I can see here that I've got two versions of code, right? This is a database, what I've got on my side, and this is what I've got on this side. There's a number of compare tools out there that will let you do this, and you could look at a file in your file system and compare it to what's in your database, or look in version control and compare it to what's in your database or file system or whatever. Okay. So this way I can look at it. Now in this case, the tool, whatever tool you choose to use, they all will typically mark off where in the particular file something is changed, and then you can decide what to do there. Right? Do I want to make this change, or do I want to change my code? Do I want to change that code? Something like that. Does that answer your question?
Yes. Basically, I'm guessing this is more just comparing your local version versus the one that's been pulled.
Yeah. So this is what's been pulled or pushed, right?
Yeah.
This is what's in my Git repository.
Yeah.
Because it's the version control version. This is what's in my database or in my system.
Yeah.
You know, I mean, there's any number of ways I could do it. I could generate the script for that object, and you know, in source tree or for this Git, I can compare that to what's in another file system. There's a bunch of database compare tools, but there's all kinds of source code control. There's compare tools like Beyond Compare, KDiff, or different tools that will let you look at two files, and it'll give you a representation here of what's changed. It'll typically highlight the items that are different. It's hard to see, but this line is actually yellow on both sides.
Yeah.
And then typically they'll use some marker that tells you where in the file something has changed. Yes, sir.
What I might be trying to get to is if I was changing resources in my box and you change on your box,
What would happen?
is there an image conflict?
Yeah, there absolutely is. And let's push this out. And I'll show you that in just a second. Let me keep going just in oops. Where am I at? And I'll come back to that in just a second. I'll do the merge thing. So there's all these things, but essentially the whole idea of this version control is that we have some version of the truth now between all of us. So if you're a developer and you're a developer and I'm a developer, we're all working together. How do we know what code is good? Right? Probably not your code. Might be my code. Might be your code, right? But the idea is that if we all store it in version control, we can at least figure out what each of us did, and we know what the version is. So if I change something and he changes something, we can try to figure out what we want to do, right? Because if we just have a shared database, and I change a store procedure and I compile it, and 2 milliseconds later he compiles it, whose changes get stored in the database? Last one in, right? We didn't all necessarily know what my changes were at one time. Because if I close the window and I forget all about it because I assume that my changes were in there, we don't know. So the whole idea here is really, when I'm doing, there's all these other versions, but when I'm doing collaboration, I need to have some single version of the truth. Or at least I need to be able to go find it. So if my code is buggy and his code wins, great. But if I've got things in my code that I'm responding to some request from users and he's responding to different requests, we need both of those things to get merged together somehow. Okay? So there's all these reasons for doing that. So let me look at that a little bit. So I've shown some of this. Where am I at here? You know, you have all this history, so you can see all the changes that I've been making over time. Branches. In this case, we changed that store procedure. We added an alias to one of the results but not the other one. Correct? Let's push that up. And then while that's happening, let's come over here and let's pray that this actually works correctly. Like that for some reason. All right, forget it. We'll get by. So that store procedure was get contacts ending. So let's change it here. Let's change it here. That's not what I want to do. All right. Wow, my tracking is way off. Alright, forget it. I can't even see my code now. There, that's fine. So I have an alias here. So let's say this guy decides to say, and what do we got? Let's do update. Okay, so if I make this change, this is separate from that other change, correct? and maybe I decided that I'd go, I changed something else we'll just do it so it's conflicting there. So, is that not in there? I don't know. That's probably not a good one, but let's do this. We're going to discriminate against half the world. All right, so that works. So if I were to pull stuff down, right? So typically when I do this, over here. All right, fine. I make a change, in the way that developers do reverse controls, you want to see if anything else has changed on the server before you make your change, correct? Then your developers. So here, I can do a pull from the repository. And in this case, I think I pushed everything out. Didn't I? Let's see. No, it didn't pull. I thought I pushed. Do I have something committed here? Let's see. Sorry. I broke my push from here. We'll push from here. Nope, we won't push from there. We'll push. It's really not this super complicated. I'm trying to do a lot of stuff really fast from here. So usually it's not so bad. Let's push it from here. So I push that up, and then we're over here, and let's pull it now. So I should have changes now coming through. I think we have a table, and we just have a sort procedure here that pull. And in fact, I don't have source tree as VM, but if I was doing source tree, I would see a conflict as well. And so I see that there's a conflict. And in this case, these are yellow, where the conflicts occur, where the changes are. And I've got ability to resolve things. And so I could use, in this case, I have kdiff 3 on this machine. And kdiff 3 is a free tool you can go download. There's beyond Kaveri you can buy. Visual Studio has various tools. There's all kinds of them out there. But here I see my code, the code from version control that just pulled down into the folder. And then I have a resolution area where I want to change things. So in this case, maybe I go, I'm going to take the code from there, and I'm going to take the code from me because we're trying to do things together. And I have then a final version here that is what's merged together, but it's not syntactically checked, okay? Because I'm just doing text file comparisons here. Okay, so I need to make sure that if somebody's added a column here or something else, I've got the commas in the correct places. That syntactically this works correctly. Certainly, if I try to run it through server, it'll tell me whether it is or not. But in this case, I can save it and close this. In fact, I typically would commit at this point and say, I'm going to keep mine, which has got the merge changes from them, and then I can just put that back into source control. All right, and so any way that I do this, whatever tool is inside or outside of SQL Server, this will happen, and I just work with it. Okay, make sense? All right, so let me move on to branching. I think I'm running slightly behind. All right, a couple things. So, how many of you work in a team? Multiple people working on? Well, most of you. Okay, so typically for developers, we work in sandboxes. So I do changes on my machine. I compile them. It's not affecting you at all. If you work in a database, though, a shared database, if I make changes, it potentially breaks your work, vice versa. And ideally, we do want to separate things out and have everybody have separate databases, but that's not always possible. It's not always what we want to do. So we end up a lot of times with shared databases. We need to, what we want to do is lock things. Now, some version control systems allow you to lock files, some do not. The way that we lock things in computer science is that we have respect for each other. There's no way to technically lock anything in computer science. Okay? If the process has access to memory, if you disk, you can change anything. What we do, though, is we raise semaphores in the operating system or in applications, and then the other side has to respect that flag for that semaphore that's being raised. Okay? There's multiple ways you can do this. Again, I'm going to flip over here. In this thing, let's say that I'm changing this procedure and I don't want anybody to mess with it. I've got the ability to lock this. And that comes as part of this tool where I've now locked an object that says it's locked. So I can make changes to it. So in this case, if I've got this procedure, I can say I want to, get rid of, or I want to change this thing to say, change date, which I think is the wrong thing, but that's all right. It doesn't matter. I can make changes. I can work on my code. But here's my machine, right? I'm outside the VM now. If I were to connect to that instance, what's this? I don't know. Let's see who this guy is real quick. So I connect to this instance, and I want to look at that database. It's just this database. We're working along together. If I want to change that procedure, which is here, let's say I decide to go, well, we don't really want this stuff in here. I get it locked. I actually get a message in there that says I can't change it. And if you look at this error, it says that there's a failure, a DDL trigger actually fired and said I can't do this. And if you look up here, you'll see I got a little lock icon here. What this tool has done, which is what you could do as well if you so choose, or pay someone to do it, but I built a DDL trigger that looks for changes. And if it's not made by the person that locked an object, it doesn't allow this change to occur. Okay? So all it's doing is looking to say, all right, have I locked anything? Have I put anything into the table that says it's locked? If so, then am I to use it locked it? If not, I do a rollback. If so, I do nothing allowed. Okay? So, tooling and process becomes helpful here. But all we're doing is we're raising a flag to say, hey, I want to use this. Now, certainly, in this case, I could unlock it from here. Where's lucky? And I could say, please let me break this because I feel like it, and I'm annoyed by this guy. And if I execute it, it'll work. Right? Because I lowered the flag to say, all right, any questions? No? Yes? Everybody still awake? Okay, thank you. All right. Let me talk briefly about branching. I won't spend a ton of time on this because we're running out of time. But does anybody, so some of you probably don't know what branching is. Let me just go through it real quickly. Branching is designed to allow us to work on code separately and still keep track of it. The idea is that we make a complete copy of our code, and one of us can work on a copy and one of us can work on the other code, and then at some point we can decide either put all our changes together or not. Right? The simple, or not maybe the simpler way to do this, is that typically each of these lines is time where we're doing development, and each one of those is a copy of code. So if you think of time as marching linearly this way, I work along and I make changes to code. At some point I create a branch, which means I just make a copy of this code. And the branch is linked, it knows that it's a copy of this code, not some other code. I can make changes here completely separately of what's going on. Periodically I'll do merges. A merge means, just like I did with that sort of procedure, we resolve the differences in code. So if I've made changes up here, I can then put those changes back into my branch so that we can move on. For example, if I branch to build an auditing system, right? I want to build triggers and an extra column and tables to log things. I do that work here. Maybe I add a new table here. Well, I want that table down here because I want to make sure that this person, whoever developed it here, knows how to add logging to that or auditing to that table. And then once in a while, I'll move those changes back up because I'll say that this was a good idea, it worked, move it back up. Sometimes I make it to this point and I go, this was a really bad idea, and I just delete the branch, throw it away, and don't worry about anything. But I have those options. I also typically do things branching when I release code, when it goes to production. The reason is, we all know we have bugs in our code, we make mistakes, we're going to have to hot fix production at some point in time. So I branch here because if I continue to make changes here, I can't build a patch here and release it to production because however I build a patch may not work for production because this code's changed. So typically I would connect to this branch, load all that code in my database, load all that code in my application, make the fix, and release that. When you get a CU or an SP for Microsoft or SQL Server or Visual Studio or anything else, they built a patch on their release branch. Now they also merge that patch into the next version of SQL Server or the next version of Visual Studio. But they have to keep a few branches alive. For SQL Server, typically there's 2 branches alive here and 1 here. That's why we get patches for 2 versions back. Right? Branches are problematic. So some of you that have built branches in the past realize that if we're working on our code and you decide to branch to work on customer, you decide to branch on finance, and you decide to work for auditing, we realize very quickly we've got multiple copies of code and we can lose control of what's going on. And also, I know I merged that fairly quickly. Mergers are usually fairly painful when we change the number of options. So we try to be careful about how often we merge stuff together. So in databases, how do I branch code? All right. So in Git, to create a branch, it's pretty easy. You can do it from the command line. You can do it from here. But I can just create a branch here. Hopefully I spell things correctly when I do this stuff. And what this has done is create a copy of the code. And in fact, what it's going to do is it's going to create a copy of the code here, and it's going to check it out. So if I make changes to my branch, they won't appear in my regular branch, my master branch of the code. So I have 2 different places where I can develop right now. But what happens in terms of databases? Well, for databases, what I really need to do is I need a new database. And we could argue about this, but I've never found a way to branch in the same database that works correctly for time. Typically, I have to create a new database in order for my development to proceed appropriately. I don't have a solution. If anybody has a better solution, I'd be happy to listen to you. But in this case, I don't have a better one. So here, this is what I would do, in that I would link a new database to my source control system. Git is weird in that the physical folder on my machine is the same folder. So I would link to the same place and pull that code back. If you're using TFS or Subversion, what you do is you would branch in TFS or Subversion, create a new database, and you would have a physical different place on your own machine or your own development server where you would link that code to. So in this case, I can pull all this stuff in. This will finish in a minute, and I'll have all of my code at this branch level. And we're hoping this will go quickly because we're almost out of time. Come on. Alright, so here I've got all of my code. And let's do something here. So if I make a new stored procedure here just for the sake of doing this. Once I do this, I'm going to have some new code here. We'll see that here in a second. On the branch, I've created something new. Let's scroll up, you can see it. So there's the change I just made. In fact, if you look here, here's this demo prop. Right? Everybody can see that. That exists here in this folder. They're linked to the wrong place, maybe. I think they're linked to the wrong place. It's here. So it exists right here. That's the one I just created. But it doesn't exist in my other branch. So if I were to switch to this branch, there's a variety of ways we can do this. What we'll find is that that doesn't exist. I don't even have that stored procedures folder because it's completely gone at this point in time. So each branch has different code. Now I can merge those together. I can do it in Git. I can do it a variety of ways, but at some point I have to resolve those. Essentially, if you're using Git or Mercurial or one of these distributed systems, you have to realize that the branch that I have selected here, right, in this case master, will correspond to the database that I have to work with here. So I'd have to work with this database. I was in the wrong instance, but I have to work with this database here. If I was doing development on my branch here, then I need to make sure, in this case, that I switch back to this branch, which once that happens, you'll see that stored procedure folder is back. In the Visual Studio world or the Eclipse world, you don't care about this because you probably just reload and you don't care. But in the database world, it's slightly more confusing because I have to make sure my branch matches with version control system branch that I check. That makes sense? Everybody looks slightly confused. That's all right, it is confusing. This part is confusing, but the bottom line is don't branch if you don't have to. Makes life much easier. Okay. I mean, seriously, branching is really helpful. Developers love to branch, and it works well. But in the database world, it gets complex really quickly. You do need a second database to do branch development. One for each branch. So just be careful. All right. To kind of summarize here, please, version control is important. It is valuable. It helps you gain control of your development environment, your development process to make sure that you just know what's happening at any point in time. You can always look and figure out what version of which files exist or did exist in the past or have worked or don't work. However you want to do it, whatever tools or processes or things you put in place, you got to make sure everybody understands how to use them and everybody has access to them in order to keep track of them. You can have somebody that's designated to make sure that all changes in the database are reflected in version control. You can put that onus on each developer. Doesn't matter, you just have to have something in place that works. And the last thing I'll say is, you saw me write comments periodically when I'm committing. Those comments are really for you 6 months from now. So eventually if I quiz all of you on what code you wrote last Tuesday, you would struggle a little bit to remember and figure out what's going on. Sure you could, but it takes time. The idea behind all those comments is that you can look back and try to figure out what you were thinking at the time. So please don't put I added a column in the comment. Please give me a why I added a column. Reference a Jira ticket or work out in TFS or a logical, rational reason for why I did this, not what I did. All right? So hopefully I kind of covered this. I've showed you how to store database code and version control, get it out, make changes, look at history a little bit, look at what's happened in the versions. In the branching, you can see what's out there and what's going on. And just be careful with branching and merging. I'm happy to take questions if you've got questions. If not, this session is over. Please feel free to get some coffee or tea or whatever you want. But, thank you very much for coming. Have a great day, SQL Relay, and enjoy yourself.